Okay, let's talk a little bit about how to get data into a program from the outside. So hard-coded data is what I call data that's entered right in the program itself. So here's an example of a program that I declare some variables and I hard-code the values for those variables. Okay, I put an 89 in this one, 96 in here, and 78 in here. Then I'm finding the average, so I sum up the values, and since I want to do a division by the number of grades, I first cast the whole sum into a float. And then finally I display the results down here. Okay, and you'll see that the program does sum the numbers up, divide by 3 to give an average of 87.6667. Okay, this calculation works just fine, but what if I wanted to use different values for the grades? Right. Okay. What I would have to do is I'd have to know the C++ language, I'd have to have access to a C++ compiler, and I'd have to have access to the source code for the program. And this is really a lot to ask for someone who just wants to find the average of some grades. It would be better if the program could be written in such a way that the user of the program, not the programmer, was able to enter in values for variables while the program is running. In other words, you shouldn't have to alter the program and recompile it just to put new values in the variables. A user should be able to do that without recompiling, or not even having to know about a particular programming language. Ideally, we'd like to be able to compile once and run many times. So the program would be compiled once by the programmer and then run many times by the user of that program. There are two ways to get data into a program from the outside. You can get data from the keyboard or from a file. And we're going to focus on getting data from the keyboard now and learn about files later on. So we can think of the I/O devices that are connected to the computer as being connected through this stream interface, where individual characters are sent down the stream into and out of the program. Okay. So a way to think about this is your typical computer system has some kind of monitor connected to a computer, and the computer has attached to it some kind of keyboard. Now if you have a laptop, of course these are all put together in the same package, but if you have a desktop computer like this, they might be separate components. Okay, so when the user types in some keys on the keyboard, what the keyboard does is it puts those characters on this stream, and the stream leads into the program. Okay, so your computer could be running many different programs, and there are these streams into the program and out of the program. So if I were to type in the letters of my name, for example, each one of those individual characters would be placed on the stream that is fed into the program. Okay, now this little bit of code at the top of every single program we're going to write, include IOStream and using namespace std, those provide the constructs for cin and cout. Cin is the standard interface to the keyboard, and cout is the standard interface to the monitor. And we've seen that cout is like a command to print to the screen. So when I do something like, if I say cout hello world, okay, when the flow of control reaches this line, this basically says take each one of these individual characters and send them on the stream, the standard output stream, to the monitor. And of course what the monitor will do is it will print these in our little black console window from left to right, top to bottom. Okay, there are some helpers we can use with cout. To end the current line, you can use endl in a cout. So I have a couple examples we could look at here. Comment this one out first. So let's just focus on this line right here. So So cout again is like giving us access to the stream, and this is saying put these different things on the stream. We have a string here, we have an endl, another string, an endl, and so on. And if we run this, see, this is, then the line ends, on a different line ends lines. Okay. Now there's another way to end the line using a special end line character called a new line. And the new line is just a backslash followed by an n. Okay. Now we don't have to break up the string. If we put a backslash n anywhere inside a double quoted string, that's going to be treated exactly like the endl was in the example above. Okay, so every time the backslash n character is encountered by the monitor, it will end the line by moving down to the next row and back to the left, very similar to how an old typewriter used to work. There are additional ways to help you format the output in a cout. You can use fixed, set precision, set width. So I have a couple examples of those we can look at. Okay. These examples do require that you pound include a couple different libraries. climits, or actually iomanip I think is the most important one. Set width says that whatever's going to be printed next, which is this thing called int max, should take up exactly 15 characters. Okay. Even though int max isn't a 15-digit number, and when we run it, we'll see that it does take up 15 characters worth of screen space. And since it's not a 15-digit number, it's filled in the left with these blank spaces. So set width will set the width of something that comes directly after it. Show point will show the decimal point. So a floating point number, if it doesn't have any significant digits after the decimal point, usually shows up as just an integer value. Okay, so here's the output without show point. But then if you add this little help or show point right before, you see it does indeed show the decimal point and several zeros. Fixed is a way to get a number out of scientific notation. So this number is really this number times 10 to the minus 12, which makes it a really small number. And fixed will make that show up in kind of a decimal format. Okay, so you see 0.0001. And finally, set precision says how many digits after the decimal place do you want to see. So even though there are many places after the 0.98, this only applies to printing. It will only print the 2 digits after the decimal point. So the number, if this were a variable, it wouldn't change the variable. This only has to do with printing, and it says how many digits to print. Okay, now back to reading in from the keyboard, because that's really what I want to talk about here. So remember, we want a way to declare a variable and have it filled in by the user without them having to edit the code and recompile it. And we can do this with cin. Okay, so the characters that are typed from the keyboard are placed on the stream that's leading into the program. Okay, just like I mentioned before. Okay, when you type stuff on the keyboard, it gets fed into the program. Those characters can be plucked out of the stream and placed inside variables. Okay, so I have another copy of this program. That will get the data not from a hard-coded value, but from the user typing in at the keyboard. Okay, so it's basically the same program. We declare the variables, but instead of hard-coding their values, we prompt, okay, we ask the user to type something in, and we're going to take those values and store them inside the variables. Okay, and then we're going to do the math that we talked about before. Okay, so the way Cin works is it's going to group collections of characters into blocks. And the blocks can be separated by either spaces or new lines. New line, remember, is that character, it's that \n, and that's what happens when you hit the Enter key. Okay, so if the user entered some information, let me run this one. So let me say, maybe 70 for grade 1, 80 for grade 2, 90 for grade 3. It's going to find that the average of those three are 80. That seems to make sense. Okay. If we look at, the values coming from the keyboard, from the perspective of the program, I typed in a 70, and then a new line, and then an 80, and a new line, and a 90, and a new line. Okay, and what Cin does is it groups chunks of characters that are separated by either new lines or spaces. Okay, and it treats them as individual pieces of data. Okay, so when we did this prompt, enter in grade 1, and I typed in 70 and hit enter, it grouped the characters 7 and 0 together into a chunk, and then it placed that value inside the variable called grade 1. Okay. Then it asked for grade 2, and I typed in 80. It grouped those into a chunk, again, based on where the new line characters were, and the same for grade 3. So each one of these chunks will be placed inside the variables used in the Cin statements in the order that the Cin statements are encountered in the flow of control. Okay, so 70 was going to be placed in grade 1, 80 in grade 2, 90 in grade 3, just because that's the order that the Cin statements were executed. Cin looks at the type of the variables where the data is going to be placed and will convert the block of characters to the correct type. Okay, so it took the values, the character value 70, and it turned it into the integer value 70, and it stored that in the variable called grade 1. And it took the characters 8 and 0, grouped them together, turned them into an integer, stored that in grade 2, and 90, turned that into an integer value of 90, and stored that in grade 3. Okay, so that's a really convenient way for us to get data from the user, okay, most likely in the form of the keyboard, into our program, into a variable. Then we can manipulate the variables, right, to find, for example, the average, and then see out the results. Whenever we display or see out something, the results will go to the screen. Now, we can't control the fingers of the users of our program, so if they enter in some invalid characters, the program will most likely break. In other words, if you're trying to do a Cin to an int, and the user entered in some text rather than numeric digits, bad things are going to happen in your program. And this is because the non-digit characters can't be converted into a numeric type. So let me give you an example of that. So here, we're definitely expecting the user to type in a number because grade 1 is an int. If I were just to put some characters in there, you'll see really weird things happen to the program, and it's not going to give us the right value. That's because our user kind of made a mistake. Okay, so this is why I always have a very explicit prompt before every Cin. I like to give examples of valid input. So this isn't a whole program, but if I was asking for height in inches, my prompt or my question to the user, you always have to have a prompt. You always have to let the user know what the program is expecting. So here it basically says enter in a height in inches, and then what I like to do is give examples. So, for example, 72.5 is an example of the input that we're expecting. If they type, I'm 5 feet tall, when the program was expecting a numeric value, there's no way really for the computer to infer the number 60 from that. And with these black console window applications, there's only so much we can do to kind of idiot-proof our programs. So as long as you give a decent prompt, when I'm grading your work, I'll try and obey the rules of your prompt, or I'll look at the examples and I'll do the same thing. So I'll try not to be too much of an idiot. Okay, so that's input and output to a program. It makes programs much more usable than if people actually had to edit the source code. And we're going to be doing quite a bit of this pretty much in every single program. We'll read in from the keyboard and write out to the console window.